Hello, high achievers and motivated learners. Welcome to our math class. I'm your instructor, Mr. Gutierrez, and today we're going to be learning about graphing in coordinate planes. Before we begin our lesson, we must be mindful that we are champions of our own learning. And to be a champion, we must listen when others are speaking. We raise our hand when we need help. We stay focused and on task to the activity at hand. We stay in our seats unless instructed to do otherwise. And participation should be giving it your best at all times. Before we learn about graphing in coordinate planes, we're going to see what we already know. And for our warm-up, we're going to take the numbers -6, 8, -3, and 11, and using approximation, we're going to plot those numbers on the two number lines you see. You have 10 seconds to complete the task. Ready? Begin. Great job. Thank you for participating and writing. Ready? 3, 2, 1. Excellent job, everyone. I want you to check your answers and keep this warm-up until the end of the lesson. You're going to submit this with your exit ticket and see how much more you know from the beginning. Before we start learning how to use graphing in coordinate planes, it helps us to understand what we use graphing in coordinate planes for in real life. One particular use that I'm sure most of you are familiar with is how we use graphing in coordinate planes to locate boats in the ocean, airplanes in the sky. Or you think of other uses, some careers and jobs that require high proficiency or skill in graphing in coordinate planes are architecture, engineering, computer and information technology, and so on. So we know what graphing in coordinate planes are used for. What exactly are they? Well, graphing just means making a visual representation of math. It's like a window into the abstract world of math. Now that we know what graphing is, what are coordinate planes? Well, coordinate planes are the actual platform that our graphing takes place on. And like I said, graphing is like a window into the abstract world of graphing. Our coordinate planes actually look like a window. So now that we know what graphing and coordinate planes are used for in real life and the definition of them, how does it work? Well, to help us understand that, let's think back to our warm-up at the beginning of the lesson. We know on a horizontal number line that when the number is positive, we move to the right. And when the number is negative, we move to the left. Now on a vertical number line, when the number is positive, we move up. And when the number is negative, we move down. Now there's a couple of things that you might have noticed about this diagram. One is that the two perpendicular number lines intersect at their 0 point. That 0 point we call in graphing the origin. Another thing that you might have noticed is that there are these marks showing the numbers along the way. These things combined create our coordinate plane. Now, if we extend these marks infinitely, we get our two-dimensional grid known as the coordinate plane. Now, how do we use this coordinate grid? Well, to help us, it is easier to understand how we use the one-dimensional number line. And when we plot numbers on the one-dimensional line, we can plot them in various points along that number line. But no matter how many points that we plot, it will always remain linear. On a two-dimensional coordinate grid, we can plot points anywhere on that coordinate plane. And this opens up a whole new world of possibilities. Now let me ask you a question. If we need 1 point to plot a number on a one-dimensional number line, how many points do we probably need to plot a point on a two-dimensional coordinate grid? If you said 2, excellent job. Now what are these two numbers and how do we use them? Well, in graphing, we refer to those two numbers as an ordered pair. And this ordered pair follows a specific format. And that format always consists of two numbers separated by a comma and surrounded by parentheses. Now, to make things even easier, we also keep these numbers in that exact order at all times, and we refer to those numbers by their variable names, x and y. And in this case, x equals 2, y equals 4. So now that we know the format of our ordered pair, how do we transfer that onto a coordinate grid? Well, our coordinate grid actually makes this easy for us too. On a coordinate grid, our horizontal number line is referred to in its variable base named as x-axis, and our vertical line is referred to as a y-axis. So how do we plot our ordered number using this information? Well, in this case, we know that x equals 2. So we know that our point should be on 2, but that our point, if x equals 2, our point can be anywhere along the y-axis. In this case, we know that our point y is equal to 4, but it can be anywhere along the x-axis. Now, what you might have noticed is that these two lines intersect at an exact point. This exact point is the only point that in the entire grid that represents the coordinates x2, y4. Now, now to help you with an even more simpler and intuitive way to reach that, to graph that point, we start at our point of origin, and our x tells us how many units to move in the x direction, and in this case, 2. 1, 2. Our y tells us how many units to move in the y direction. In this case is 4. 1, 2, 3, 4. Excellent. So now that we've learned how we use an ordered pair and plot those points onto a coordinate plane, let's practice. First coordinates are 5, 3. I want you to take your cursor and place it onto the coordinates. 5, 3. Ready? 3, 2, 1. If you answered +5, +3, excellent job. Number 2, think of or write down the coordinates for this cheerful emoji. Ready? 3, 2, 1. If you answered -4, +6, excellent job. Number 3, place your cursor on the coordinates +2, -2. Ready? 3, 2, 1. If you guessed or answered +2, -2, excellent job. Number 4, think of or write down the coordinates for this emoji. Ready? 3, 2, 1. If you answered -7, -5, excellent job. You are on your way to mastery levels. There's a couple things that you probably noticed about the placement of these emojis. First is that they're each placed in their own individual sections of the coordinate grid. Now those sections are actually known as quadrants. And these quadrants are labeled in a numerical order counterclockwise. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Another thing that you might have noticed is that each coordinate point has an exact representation in each quadrant. Quadrant 1, the x will always be positive and the y will always be positive. Quadrant 2, x will always be negative and y will always be positive. Quadrant 3, -x, -y. And quadrant 4, +x, -y. So if I was to tell you that my location was at -4, -4, you should automatically assume that I am located in quadrant 3. Quick check for understanding. Stop and go lights. Excellent job, everyone. Now for a recap on everything that we learned in this lesson. We learned that when a horizontal and vertical number lines are merged at their 0 points that we call an origin, it creates a coordinate grid called a coordinate plane. That coordinate plane has 4 quadrants. And in a coordinate plane, the horizontal line is referred to as an x-axis, and the vertical line is referred to as the y-axis. We also learned how to use an ordered pair to graph coordinate points onto a coordinate grid. And these points allow us to visualize math in a 2-dimensional way. Excellent job, everyone. Before class concludes, please complete the exit ticket and submit it with your warm-up from the beginning of the lesson. And then we will start our pair off to play our coordinate game, Battleship. Awesome job, everyone. Excellent class and great participation. I look forward to the very next one.
Let me introduce you to the coordinate plane, the map that reminds you of the Battleship game. You came to instruct the beats.